our modding tutorial series. In this tutorial, I will be going over skeletal mesh sockets and what they entail, how to locate them, how to find the values and parameters for each of the sockets, and how to add or implement them into your mod. So for this example, I'm going to be finishing up my abomination mod using Zangief's base. This is Zangief's mesh file. I just added an A to it to make it distinguishable when I extract it. To extract this file, we use UModel. There's UModel here. And a program called Unreal Package Extractor, which is actually this extract.exe file here. I've created a bat file for this to make it compatible with Street Fighter V files. I've uploaded this batch file several times on the Street Fighter V modding forum, so you can locate it there. I'll go ahead and show my command line real quick for those who are not following us on the modding forum. This is my bat file. So, as you can see here, these are the skeletal mesh folders, the ones that actually have the mesh number. I have one here for Zangief. This is the original, untouched, unmodded Zangief mesh folder extracted, or mesh file extracted. I'm now going to extract my modded one so we can compare. Very simple, double click that, creates a new file. We go into here. As you can see, clearly there's a difference. My modded file only contains the root folder with the skeletal mesh. Here are the three tables. These three tables are common across every single Unreal Engine game and file. It's export, import, and name tables. They're extremely important, and every single file will include all three tables. This is the original Zangief. As you can see here, there's a folder under the name of the mesh. If we go into this folder, we'll see that there's two socket files here. The skeletal mesh sockets. For Zangief, they're socket 13 and socket 14. So what are these sockets? Where do we get them? How do we add them? And how are they created? And what's the purpose of the sockets? Well, to find that out, we will be looking at two different documents today. Export table and name table. For comparative sakes, I've already structured how a skeletal mesh socket file works. First, I'm going to open up my hex editor, which I have here, and we're going to add Zangief's original socket 13. This is the actual file. It's broken down into both 4 and 8 byte variables. Each 8-byte variable, as highlighted here, is a name table structure. They're all written in Big Indian, so we have to reverse them to Little Indian, meaning that 0169 is actually in hex 169. 169 refers to item number 361 in the name table. So we open up Zangief's name table, 361, and then item 361 is socket name. As you can see here, I've already mapped this out. This is the standard structure map for every single skeletal mesh socket file. They're the same across every single character, every single costume. What's in quotations is a name table entry as we've located here, number 361 socket name. So in every skeletal mesh file, searching by 8 bytes, we're going to follow these now. The first 8 bytes is socket name. Second 8 bytes would be name property. That's name property. Then we have hex 8, which is this. Hex 8, you read 8 bytes over. What's the next structure? Is socket name. Okay, socket name change is I put here an asterisk because it is relative to the name listed on the name table. It's not a standard structure. It'll change depending on the physical name of the file. So for Zangief, we look at 167. I'll just use my hex calculator really quick. 167 is item number 359. So looking at his original file, which is this one, search 359. We see here item 359 is a socket called sock_crown. So that would be the actual name of the socket that we would need to add. If I'm looking at my extracted, this is my extracted modded file, and I look at name table, you'll see here item 359 is missing, and there is no sock crown anywhere here because I have not created that file, and it's not part of a mesh. We need to create these bone sockets individually per costume. I would recommend highly that you follow the same naming structure used in the original files. It just makes everything streamlined and less tedious, and eliminates or at least dwindles down the possibility of there being any type of conflicts or problems in the future because of bones and sockets not being named correctly. It's actually fairly simple to do. I'll show how to do that in a second. So the first thing that we want to do, well, that's the socket name. If we look back at my structure map, so please, this one, yes. Oh, that's the original. I can close that. This one. Looking back at the structure that I've mapped out here, it repeats again for bone name. So we found socket name, it leads to a socket name. Bone name is the same idea, bone name property, hex 8, and then the actual bone name. So in this instance, the bone name is BC head, I believe. Let's just verify that by looking at it. And hex, remember, we're Skeletal Mesh Socket 13. So we're looking at the next hex 8, which would be this, and then this is the bone name, which is 12 in hex. We convert that to decimal using our calculator. So 12 in hex, 12 in hex, oh my god, is 18 in decimal, I'm sorry about that, which is BC head. See, item number 18 on the name table is BC head. So, this is the bone that we need to create a socket for. I'm going to show how to do that shortly. And we will need to repeat the process for socket 14. So, let's go ahead and do that now. In Unreal Engine, okay, you can go to your mesh editor. Now, I've separated mine to make it easy for myself to work. This is the main viewer editor with mesh. By clicking on window here, you can add different windows into this area. Normally, it's just viewpoint and mesh details. I've added a details pane and skeleton tree, so I can do all my work in a single window instead of having to tab through these. I don't need to do that anymore. Just simply go here. Now, as I stated just a short second ago, we're going to be working to add a socket to BC head. So first we have to search for that. So how do we do that? It's very simple. In the skeleton tree, B_C head. This BC head. Now, adding a skeletal mesh socket is simple, but there's there's a structure you should follow. First, right click on the bone name, in this case BC head, and you're going to click add socket. And here, this is the actual socket name. So as we discovered earlier, this is sock_crown. That is the socket name. Now, we have to determine what type of socket it is. See here, you can see socket name, sock crown, bone name, B_C_head. So so far we're following the same structure as outlined for the original file. Now we need to determine whether This is going to be a regular mesh socket, which, as you can see in the bubble, it says duplicate the socket from skeleton to current mesh and modify the socket data. That will allow the mesh to use the socket that is being shared on the common skeleton. That's one type of bone socket. And then there's a bone socket specific to the mesh, which is a mesh only bone socket. How do we determine that? Although I haven't verified this with any type of 100% certainty, what we can do is go to where the actual export is. So for example, using, I don't know what I just did there. Okay. Excuse me. This batch file that I have here, it says drop U asset here for mesh. This is using UModel's list command to scan any asset file and generate a mesh text file based off of that with offset and location. So I'm going to drag my modded file over it. It'll create a text file with the duplicate name. Here's one for the original Zangief. The way this works is this is the 3 meshes that are located in the EC2_01 USF file, which is Zangief's primary costume. Really quick to explain what you're looking at here. This is written in big Indian, so again will need to be flipped for use on PC. But this is line number. The first number is line number or item number, whatever. Second one is offset location or starting offset of the file associated with it. So Skeletal Mesh EC201 in the actual mesh file, or the UASF file, which started off offset 2198. This is the file's size. So we want to find Skeletal Mesh Socket 13. We want to find this entry in the export table, which is what this is generated from. This text file here is generated from the physical export table in the UASF file or any Unreal Engine file. So using, I don't need that, using the original mesh, because this is the one I'm looking at now just for continuity, we're going to search for this export table entry. Again, we have to reverse the Indianness of this entry. There are 2 4-byte entries. One, the first 4 bytes here is offset location. The second 4 bytes is file size, but we have to treat this as an 8-byte string and reverse the Indianness. So we're not going to be reversing this 4 bytes and then this 4 bytes. We start with these 4 and work backwards. So to do that in Hex, when we do a Hex search, the first 2 bytes will be A4, and then we fill in the remainder. Sorry, the first byte would be A4. We fill in the remainder of the 4, which is 3 bytes left, with nulls. So that's 3 nulls. So that takes care of this 4-byte string. Now we have to reverse Indianness this 4-byte string. That's what comes here, which is very simple. FA CB 3B00. When we search for that, that's this entry in the export table. We are now in the export table. I'm going to explain to you how the export table works. This 6210 is a name table entry. This is standard across every export table entry as far as in relation to Skeletal Mesh Socket. I mean, generally, if I go back these 4 bytes here so I can find this, which is 06ABO, is this right here. I look back 4 bytes, that'll be the name table entry 80 here, which should be the actual file name EC21. With Skeletal Mesh Sockets, name table entry of 162 points in the name table to skeletal mesh socket. This number is going to be different, of course, depending on the character, because a name table number, the hex number or line number for a name on a name table changes depending on the size and how many items are in the name table. But the actual name will be the same in this instance across every character. They will all be skeletal mesh socket. So we have skeletal mesh socket. This here's socket number. Well, actually, it's the first 4 bytes. This is not an 8-byte string going to name table. This is actually 4 bytes separated. The first 4 bytes, 0E, is socket plus 1, for example. So this would be skeletal mesh socket 13, which is actually socket 13 plus 1. So in hex, if we do 14 hex, sorry, decimal, we do 14 decimal, we get a hex of E. That's it, 0E. So that would be skeletal mesh socket 13, because that's 13 plus 1 is 14, which gives you a hex of E. The second skeletal mesh socket is number 14, so that would be an F, because F in hex is 15 decimal. So if we scan here, the export table goes in order. All export items are listed in order as they appear here. So the third and last item in the export table is going to be skeletal mesh socket 14. So that would be right here, skeletal mesh socket 14. Now, this next set of bytes, 8 for number 14 and 0 for 13. 0 means mesh only. 8 means the regular mesh, meaning that it's shared between the mesh and the common skeleton. So making our socket here, we need to create mesh socket. Right, now I need to exit out of this so I can actually see what I'm doing. We'll see this added here. And then after we create the mesh socket, we copy selected socket, right click back on head and paste it. And that creates a mesh only socket. We can now delete the first one that we created and rename this one from crown _0 to just crown. Okay, now we're partially done. We've actually successfully created a skeletal mesh socket with the socket name of crown and the bone name of BC head. The number itself will get generated automatically through Unreal Engine. I will show how to change it in a second, which is basically what I was going over with in looking at the export table entry in hex. We'll physically open up the file in hex and just change whatever number here that it assigns it to the skeletal mesh bone socket number that we want, so that it'll match the original package. Now comes the actual values. Every socket has 3 changeable values: relative location, relative rotation, relative scale. That is what I've mapped out, which I have posted on the Street Fighter V modding forums. The skeletal mesh socket structure, I can close this because I don't need this anymore, and it's just causing issues for me now. So as you can see here, I've structured it out. It'll start with relative location, then it'll move to relative rotation, and then the last one would be relative scale if the socket requires it. XYZ is the X, Y, and Z axis here for location, and PYR is in the rotation, which is pitch, yaw, and roll, in that order. So when you're looking, where we're going to look now at the skeletal mesh file in hex, you need to follow that order. The reason we need that order is looking at the original file, we're going to find that information here. Okay, these 12 bytes are the 3 4-byte floats pertaining, excuse me, sorry, need some water, pertaining to relative location. Sorry about that, guys. So you can use a simple float to hex converter. I use a website for that, which is, where'd it go? This is what happens when you're not prepared. I just skipped over it like a jerk. Okay. This is the website that I use. You can go to this website. From what I've been able to ascertain, Unreal Engine 4 uses the floats that you'll convert through this website for the most part. The only time that I would recommend using a secondary site, which is the one that I'll show in a few seconds, is when this gives you a float value of either 0 or -0, in which case it was unable to convert the hex correctly, and there's another binary website that you can use to get the float for that specific instance. Although it's not 100% accurate, it is close enough for our purposes. Now, looking at XYZ, technically speaking, I guess, if you wanted to, you can just enter anything in there, open up the package when you're done, and just replace the entry in there with what's written in the original file. But for learning purposes, we're going to be converting each of these 4-byte floats from hex to floating point and entering them in the appropriate areas, so you can see how this process works. Going forward, it's not really necessary to do so because each skeletal mesh socket file is structured exactly the same. So once you create your modded character, you can enter in this area whatever float values you want. Once you cook your package, you open it up in hex and just replace what Unreal Engine wrote in there with the ones from the original file, which will be the exact float numbers that were there originally before you modded the file or the mesh, what have you. But for learning purposes, we're going to go ahead and just convert things over now. It's always nice to learn something. So these again are big endian. We have to reverse them. So this is going to be 368637B. That'll give us a float value of 0.0004, and we enter that into the first field for the X of our relative location. And then we're going to do the same thing for Y and Z, which if I remember correctly, it's like -90 or something, -18 I think. It's the next one. C190 and 4020. So that's -18. -18 and 2.5. So that's what we'll type in here. -18, 2.5. And now we're going to add our roll for the next file. So as you can see here, sorry, maybe I should show this so you guys can follow clearly. So I have just these three 4-byte floats are the first 4-byte floats we see here, which were for relative location. As we saw on X8, we got the bone name here, which was head, and then relative location, structure property, hex C, vector, and then the vector parameters, which are the three floats for the vector of relative location. The next structure is this one, which is relative rotation structure property, hex C, rotator, and then the 4-byte floats for the rotator of the relative rotation, which will be PYR, pitch, yaw, and roll. So we can see here the last one in the sequence is roll. That's these 4 bytes here. So we got to convert C2B4 over. Back and float. Where'd that go? B2, C4. Okay, you see how that gives us a negative 0.00. So in this instance, we're going to want to use another website to convert that hex. Make sure that I got that correctly. C2B4. Okay, that's right. C2B4. Okay, so it's negative 90 is the roll. Roll, negative 90. Okay, now we finished our first socket. Now we map the second one, or Skeletal Mesh Socket 14, which ends up being pelvis. Because I'm trying to progress here a little quicker. We don't need to remap everything. You guys should already have been able to follow what we did for the first one. We could do for this the same thing for the second one. This is B C hips, which we find in the name table. Not BC hips, that's wrong, sorry. Socket. Sock hips. That's sock hips. And we find that in the name table here. Maybe it's hip. Is it hip? Sock hip, okay. It's my fault. Now this one, in the export table, is an 8, which means it's shared on the skeleton. So unlike this one, which was a 0, we made mesh only, this one is simple. All we do is create mesh socket, and we're done with this. Now we assign the values here, again, because I can just copy and paste later. For the sake of speeding through this, I'm just gonna go ahead and, well, I guess maybe we should map that out too, just to make sure everybody's following. Let's see, where's the file? This is my modded one. Sorry, I'll just go here, it's easier. Come on. Well, again, we will be converting these over. Yeah, as a matter of fact, let's just do I'm just gonna do them as I see them on the screen here. It's 4334. So that's 180 on the roll. Okay, this is going to give me a -0, which is actually -3, I think. And D4. Yep. Okay, this is the other site that I use thanks to the Thinny, who made me aware of this secondary site used to convert Hex To Float. It's a good site, it's actually fairly accurate. However, for some odd reason, Unreal Engine doesn't use the method that this site uses, which is why I don't use it too much. Okay, so we will go new conversion, A781. Let's see, D4. You would think that conversion to decimal would be universal, because you're doing it to floating point single precision, but for whatever odd reason, the one that Unreal Engine uses is not. Oh, the rest of these we're going to get from this site. Close that yet. Okay, convert that. Pop it in here. And then we'll convert the last one, save it, and cook our package, which is this. And don't worry guys, I'll include links to the websites that I use for my conversion process. I'll include links to any white papers that not white papers, but specific structures that I've had to write out to make it easier for you guys to get. And anything else that may be difficult to ascertain from just viewing the video. Okay, so we've made all our changes that are necessary. We can go ahead and save this. I can close this. I save my entire project. And now we are going to cook our asset. Oh, that's cooking. I'm going to go ahead and prepare to extract this file again. That's because it's no longer there. Okay, and that's done cooking. So let's grab that. Should be this one. So this is what we just cooked. And now I'm going to show you when I extract it. It's going to be exactly like the original one, which is what we wanted. I'm going to delete the previously modded extracted folder. I'm going to delete the previously modded file. This is the export table from my previously modded files. You see here there's only one export, which is Skeletal Mesh. We're going to delete this as well. Let's paste a new cooked mesh. Change that to A. I'll create a new mesh list and I'm going to re-extract this. You can see now it has the folder with the two sockets. Now, see here it's socket 90 and 93. Unreal Engine will continuously name sockets as they're added, even if you delete them from the project. Unless you start a new project, those skeleton mesh sockets will just continue to increase in number. We'll change that now manually. The point was to create an export table with the actual entries and to have it in a folder structure as it's located here with the proper name table entries. So now we have oh, wait, let me also show you, just for continuity's sakes, how this is our 13, socket 13. It's named 90, but it's socket 13. You'll see here how it's structured here. These are our floats that we entered, our 3 floats. So we come over here to Zangief's normal one, pop in number 13, and we'll see the floats are the same. BD378636, BD37836, just because we entered in the correct values in Unreal Engine, so it generated the correct file with the correct values in it. So this is exactly the same. Now we're going to open our modded file in Hex. We're going to search again for the first structure here. Sorry. In the export table, I have too much crap open. I can close that. To Hex search A4. Must have typed something wrong. FA. Oh. Sorry. It's my fault. Let me do this again. Oh. Huh. Again, my fault. I'm looking at the wrong one. It's this one. Sorry, guys. I'm already getting a little... Come on. Alright, so we're going to change this, which is number 90. It's actually 91, but if you guys remember, this would be 0E, and then the next one, which is this, would be 0F, and that should be, if I remember correctly, 13 and 14 respectively. In fact, I'm not even going to double check that. Okay, and I was actually incorrect in my assumption earlier. As we can see here, let's open this back up because we need to clarify this. Okay, so the socket hip, which we made into just a regular mesh attachment, this is 00 in the export table, as we can see right there, 00. The one that we linked to make it mesh only, which was this one, which was socket 13, is 08. So these are backwards right now. This should actually be mesh, and this one should be mesh only, because going based on the original files, socket 13 was 00 and socket 14 was 08. So we would need to copy paste and delete this. And then come back down here. And for this one, we would promote skeleton, which changes it back to the regular mesh socket. Save this. Save our project and cook this again. So I'm not gonna save this one because I want to make sure that I'm getting it directly from it being cooked and not from me creating it. Damn it. Sorry about that. Oh. Okay, so we're going to do this part again. Okay, so we change this. Yeah, it looks like I would need to do this from scratch. Well, I'm just going to physically change it here. I would need to do this from scratch. I'll make sure to document this on the forum so you guys don't make the same mistake I do. Doing it from scratch seems to be the only way that you're going to get the correct values here. I'm going to make this 0E, 0F. Anyways, these are the socket numbers, and you'll see now when I extract them, they'll be the correct socket numbers instead of the 80 and 90 that it was when we first cooked it. So I just, wait, hold on, just to make sure you guys get a clear picture. This is the one, this is how it was out of Unreal Engine now, 90 and 93. We're going to go ahead and delete that. Now you'll see that the 13 and 14, 13 and 14, because we've numbered them correctly within the file itself. Now we can just rename this and add it back to the game. Now, fire up my mod and make sure it's working. Now the whole reason that I did this is because of an error that I encountered. So this garbage.
Hillside Plaza. Zangief. Cyclones!
Yeah, I know, it's ugly and nasty looking just like I want it. Okay, so this mod has weird error.
Muscle was not built in a day.
B trigger.
Ready?
How the B trigger is supposed to look. On this side,
Ready?
backwards. It doesn't really affect the hit count.
Ready?
You can see there's an hit count as you go from this side.
Ready?
This looks weird. So the purpose of reattaching those bones, sorry, those sockets, is to attempt to fix that. Saw. initially thought about how the sockets created was referred to in the export table was incorrect. So mesh only is 08 and mesh is 00. So going forward, when you look at your export table listing, if the connection type says 00, make sure that you're only making the mesh. If it says 08, then make sure you're doing mesh only, which would be to copy mesh and then paste it back in and just rename it so that the naming standard fits. So I'm going to have to delete this entire character and re-import them. Otherwise, the names in the sockets that I've attached here will stay there even if I delete the skeleton, because Unreal Engine is going to keep a backup of that, so it doesn't really matter. Let's see if I delete. Well, actually, I may be incorrect, because if I save it, I should save it. And then, let's see. Create new skeleton. And we open this up. Oh yeah, see, it's still there. So I have to empty out my actual mesh. So we can start from scratch. Anyways, I'll do that later. The point was to get you guys up to on par with how to implement skeletal mesh sockets. You now know where to look, how to locate the structures, how to find the location of the actual socket number, how to manually change it, how to add the sockets, how to add all the variables. I'm fairly certain I covered everything in aspect to this specific issue with our custom mods. Again, if you guys have any questions or comments, leave them in the comment section below. Don't forget to leave a like, subscribe for more. If you have a specific request or you want a tutorial for a specific aspect of modding, just let me know in the comments below. I'll be more than happy to make it. Thanks everybody for watching, and have a wonderful day. Thanks.